So I recently picked up a set of aftermarket cylinder heads for my Gen 5 454 that's going in the Chevelle. Now these are made by Speedmaster or Speedmaster79.com. We're going to do a full teardown of these cylinder heads. Every time I've bought an aftermarket set of cylinder heads, they can go one of two ways. They can be fairly good, or I've seen them be very, very bad. Some big name aftermarket cylinder head companies with horrible run out. The concentricity of the valves and the seats is absolutely horrible. Or the machining is not that good. The runners need to be cleaned up. Well, we're going to tear these heads down and do a full visual inspection on them. We're going to CNC the runners. We're going to CNC the chambers. We're going to check the valve seats and the concentricity on those. We're going to check all the spark plug holes, make sure that they're correct, make sure that the threads are all good. It will be a full teardown, and this is what you have to do when you buy a set of aftermarket heads, either you or your machinist, to make sure that they are ready to bolt on the engine and everything is as they should be coming from the manufacturer with a fully assembled cylinder head. So we'll jump right in with just a regular visual inspection of these cylinder heads and see what they look like. Now, the visual inspection is just that. It's not anything scientific. You're just giving it a good visual inspection to make sure that everything looks good. There's not any obvious defects or gouges that may have occurred during shipping and in the face where the gasket lays on the intake and the exhaust and on the head gasket. You just give it a good visual inspection of it. Now, these are a sand cast cylinder head, meaning that it's a compressed sand type material that's used to form the mold that the aluminum's poured into. And you can see that on the little ports here. You can see the sand cast line that's in there. You're just looking to make sure that there's no extra material there. There's not any heat cracks that have occurred during the process or when it was cooling. We're just looking for some general basic things. I've bought aftermarket cylinder heads in the past where some of the holes aren't tapped for spark plugs, for the headers, intakes, you name it. You just have to give it a quick look. You don't want any surprises after you've already bolted and torque these things down and you're trying to bolt up a set of exhaust manifolds or headers or whatever, and something's not there, hadn't been tapped. So we're just a general visual inspection, make sure the coolant ports are there and there's nothing blocked in there. Take a good look at the valves and the seats and make sure that the valves aren't sunk down into the head too far. These all look pretty good. I don't see anything visually odd about these cylinder heads. They look like a good quality aftermarket casting. As far as the runners go, we don't know anything about them. So we're going to have to actual measure to make sure that the CC of these runners are what Speedmaster says that they are. So we're going to measure that here in just a moment. But right now we're just taking a look at all the little details. One little thing here is where the guides are pressed into the cylinder head. That little part that's cast into the cylinder head where the guide slides through, you need to take a quick peek at those. If you don't, I've seen those sometimes where when the guide is pushed through, if that material's not thick enough, it'll split that little area that it's pressed into, and you just need a quick visual inspection to make sure that none of that stuff has occurred. Everything with these cylinder heads looks really good. Have no problem using them as they were right now. If everything else is equal, they look fine. So our next step beyond this is to do some actual measurement testing. But before we do that, we also need to make sure that the gasket faces are right. So we're going to check that next. Next, we want to take a look at the gaskets and make sure everything lines up here perfectly or the way it should. Now, these cylinder heads don't come with gaskets, so you'll have to go out and buy these separately. Cylinder head, intake, and exhaust gaskets. I'm using Felpro on this build. It's just a regular NA build. It's not a high compression engine. It's not boosted. I'm very comfortable using this type of Felpro cylinder head gasket, no problem. All we're doing here is just making sure that everything lines up correctly, that the bolt holes are in the place where they're supposed to be, that the coolant passage holes are perfect and lined up. Really, the most critical thing is those passengers, the head bolts or studs that you're going to use in it, and to make sure that none of the material hangs over into the chambers. You'll really get into some problems there. So as long as all of those things are good, you're fine. Now, if you look at a set of factory cylinder heads, none of these are perfect either. The castings aren't that perfect. The gasket manufacturer has to kind of cheat it a little bit so it fits everything. So they're never perfect. That's why a lot of times when you get a intake or an exhaust gasket, people port match it, which is a bit of a waste of time. But they'll never be perfect. You're just looking for the big major things. This looks good. It looks as good as any other cylinder head that I've seen or used in the past. I've got no problem using it. Intake gasket side is the exact same thing. We're just making sure that the runners line up, that when the intake manifold gets bolted onto there, that everything's going to line up, the holes line up. There's no material that's kind of hanging over within the runner. The bolts are in good accessible areas, and the bolt will pass through there without shifting the gasket around. So everything on this looks good so far. The gaskets are looking very good. On the fitment, again, no problem with either one of these. The exhaust gaskets I don't have yet. I will probably use a special gasket for that, just simply because no one likes header leaks, and I don't like using very inexpensive headers. I use a very thick flanged header, so I'll get gaskets that are made exactly for that header. So gaskets and visual inspection, both good so far. Let's move on to doing some actual measurement. And the first thing we're going to do is we're going to measure these runners. So we're going to first by measuring the cc volume of the intake runners. Now, before we get started on this, I just want to tell you to be a little careful with a big block Chevrolet, that the rocker arm studs actually go into the runner. It's a very poor design by Chevrolet. It is what it is. You just have to be aware of it. So before you actually start putting fluid in there, you need to put a stud in there, seal it up so none of the fluid comes, running out of there as soon as you start adding it to the runner. So I always use a little bit of petroleum jelly on the stud. You can't use too much of it. You just need to put a bunch of it on there, run the stud down, and that way it'll seal up, and you'll get a better, accurate runner volume, because that's the way the stud's going to be, when it's installed. Now, I didn't put the the guide plates on here. It's not going to be that much of a difference in the volume. The other side of that is the valve. I always knock the valves out and then throw a little bit of Vaseline or petroleum jelly on the valve face as well. It's just, I'm going to clean these up anyway, take them completely apart and clean them anyway. So a little bit of petroleum jelly in there's not going to hurt it. You're just sealing it up. So in this case, I'm using alcohol and a little bit of food coloring so I can read it a little easier on the burette. So just want to make sure it all stays in there. So just like with the valve and any hardware that goes into the runner that you sealed up, we're also need to seal up the plate that goes on top of here that the fluid goes through. You just want to make sure it's sealed up. And then we're going to just start adding fluid into these heads. Now, this is a 100 cc burette, so you'll need to be a little careful when you have to fill up multiple ones of these to measure a volume of a runner. Now, these are a 305 cc runner, if I remember correctly. We're going to find out here in just a minute. So we're going to need to fill this at least 3 times to get the right measurement of what the actual runner is. So in this case, everything's set, everything's sealed up. Now we're just opening up the valve and slowly adding the fluid into the runner to get a good understanding of how much volume is. Once you're down to actual 100 cc's, shut the burette off, shut the valve off, and then refill it, and make sure you just mark down or remember how many times you've refilled it. So in this case, we put in 100 cc's. We're going to continue to add cc's to it until we get to the actual volume of the runner. Years ago, when I was very young and was learning all this stuff from a machinist, he taught me that when you're measuring the runner volume, that you use a like a sports bottle like this is, that has a big long straw in it, allows you to add the material or the fluid into the burette a little bit easier. You're not spilling it all over the place. And when you're done filling it all the way up and measuring it, you can use that the straw on the bottle to extract the fluid out of the cylinder head, so you're not just dumping it on the workbench or into a sink or whatever. So it's just a little trick that I learned years ago, and I think it's fairly popular. I think pretty much everybody does it. So again, you're just going to continue to fill up the volume in these runners till you get to the final amount and however much it's going to take. Now, for the intake runner, Speedmaster advertises that these runners are 300 cc's by volume. By the amount of fluid that we've put in here, which has been 3 full burettes and exactly 5 cc's additional, this is exactly what these runners are. These are exactly 305 cc's. Now, that's pretty standard. When you're buying an aftermarket head, you'd hope that they had gotten that right anyway, that the volume of the runner is perfect. These are. So as far as it goes, quality-wise, these match up with the highest quality aftermarket cylinder head that you can find out there. These are exactly 305 cc's. I did 2 runners per head, 2 intake runners. I just randomly picked them. I didn't, do anything special with it or any mathematical or some magic formula. I just picked 2 runners at random, made sure they were sealed up, measured them, and all 4 of them that I tested out perfect at 305 cc's. So as far as the runner volume goes, these are dead on what Speedmaster advertises, and you can be very confident of what that volume is. Now, that is going to make a huge difference when you are selecting a camshaft. If you get the volume wrong on the runner, intake and exhaust, you get the chamber size wrong, and your compression ratio wrong, it throws off the camshaft pretty aggressively. So when you're ordering a camshaft with these cylinder heads and you tell the tech that you're running a 305 cc runner head, that is exactly what you have with these cylinder heads. Another check mark in the positive for these Speedmaster heads. Now let's talk about exhaust runners. Nobody publishes the information or the volume of the cc of these runners, but I always measure them not because I'm interested in what the volume is. I'm interested to see if they're all the same. If they're all the same, then I know the exhaust leaving the chamber is going to get out in the same manner on every single hole, and that's all I'm concerned about. So when I measured these, they measured at 146 cc's. Every single one was consistent. They were all the exact same. Again, another positive for these heads. Now, most cylinder head companies, every one that I've measured, have always been pretty much at that, consistency across all of the runners. On very rare occasion do you get a cylinder head manufacturer and it's usually a brand new one or a kind of a fly-by-night, eBay offshoot of a cylinder head that you'll get into trouble with these. But these are perfect. And again, it's another positive for the Speedmaster head. Now let's talk about measuring the concentricity or the runout in the valves. Now this is a very, very important step, and it's probably the most important one of all the tests that we're going to look at here today. This will tell us what the relationship is between the valve seat and the valve itself, the surface that's been ground on the valve. When they are perfectly concentric or within a certain tolerance, it seals better. That compression, all the stuff that goes on within a chamber and a cylinder head, if they're not perfectly aligned, the valve and the seat, they don't seal as well. And that becomes a problem for a lot of things. One, you get exhaust backing up into the intake runner. You get into the exhaust not sealing as well, or the intake not sealing as well, so it doesn't create as much compression there's a number of things you can imagine that happens with that. The other problem is heat transfer. If there's not a good contact between the valve and the valve seat, the heat transfer isn't very good, and the valves tend to get a little bit warmer. The seats tend to get a little warmer, and eventually you get some fatigue and some failure there. And even worse, the things tend to warp and get a little bit worse. So the valve pretty much requires that there's a good seal on the seat, so it helps transfer some of the heat that's generated from the pressure and the burning that happens within a combustion chamber. Very, very critical. Now, most machine shops, I think, will tell you on probably an OE type of rebuild that they're looking anywhere from 3 to 5 thou on the relationship between that valve and that guide. That's typically what they consider being very concentric. They're on the same kind of plane, that they kind of are working together, and they seat really well. I think most performance machinists will tell you they want that tolerance a little bit tighter, because obviously the pressures are a lot higher. Typically your compression ratios are higher, or you're throwing boost at it, whatever. So they'll typically drop that down from 2 to 4, 2 to 3 thou, and if it's not in that range, they're going to make it right to get there. So now we're going to talk about how the tool works. There is a pilot that it slides down into the guide and is tightened down. That way there's a nice tight fit, doesn't wobble around. We need to make sure this is the base of the gauge to measure the valve seat, so it needs to be pretty tight and very rigid. Then there's this gauge that slides down over that pilot tool and rotates around so it can measure what the variance is between the valve seat and where the guide is placed within that cylinder head. There's a little stem here on the side, pointer, that you adjust to ride directly onto the valve seat. Once that is touching the seat, then you can zero out the gauge and slowly rotate it around, and you can see how many thousandths of an inch are of runout that there is on the seat. So as you rotate this around, it will move according to how that pointer is riding on the seat. If it's riding on the seat very well, then no problem. You're going to get very little variance one way or the other. If it's off quite a bit, then it'll register that as well. It's a nice thing about it. It tells you how well that valve and that seat are going to seat together. Now, to give you the results on these cylinder heads, every single hole was in that 2 to 4 thousandths range. I had 1 or 2, I think, because I checked every single one, intake and exhaust. I had 1, I think, that was right at 5 thou, and 1 cylinder was at 6 thousandths. Now, to me, 5 thousandths is good. It's acceptable on these cylinder heads for what I'm doing. I don't need them to be any better than that. They don't need to be in that 2, 3, 4 thousandths. 6 thousandths for me is just a little bit off. Had I not known that, or knowing that now, would I be comfortable bolting these cylinder heads onto the 454 as it is? No problem at all. I would have no issue with that. If it was any more than that 6 thousandths, then yeah, I'd probably have the machinist knock them down, correct that one. It was an exhaust valve seat, if I remember correctly. I've got it written down somewhere, but I would have them fix it. But at 6 thou, I'm pretty comfortable with it. I don't have any issue with it. So these cylinder heads, as they sit now, are within spec other than that one exhaust valve. I have seen some aftermarket heads that are bolt-on out of the box with springs, locks, retainers, everything assembled, ready to go, made to be taken out of the box and bolted right on the engine. I've seen some of these that have been horrific with the runout in it. So always, if you're going to build an engine, if you buy a set of cylinder heads, it's always a good idea to drop them off at your machinist, let them take it apart, let them do the physical, inspection of it, and have them measure the runout of the valves just to make sure that they're going to seat properly. I've seen lots of big name cylinder heads out on the market that make very good, very high quality cylinder heads that have been way out of spec, and some that have been perfect in spec. And I think part of it is the QC process for them. It takes a lot of time to do that. And when you add time into building a product in manufacturing, it adds cost. And so most of them are trying to keep the cost under control, whatever. But anyway, just as a follow-up with the Speedmaster head, I am very, very, very impressed with these cylinder heads, given that the cost of these heads, what the condition of the valve job is on it. Very, very good. I have no issue running these as they are. Bolt on, go make a ton of horsepower. So, in conclusion, I just want to talk a little bit about what my expectation was going in and what actually these cylinder heads are. Because they are a very, very low price, very, very cost effective aluminum aftermarket cylinder head, I didn't expect the quality to be that good, to be very, very honest with you. I expected there to be some little problems. I expected the runout to be a little bit bad on half or more of the cylinders. No problem. I'd spend a couple $100 on a good valve job, get them cleaned up, and put it back in, and still would be way above what a set of cylinder heads cost on the market. Very, very impressed with this set of cylinder heads. Would I buy another set of Speedmaster cylinder heads based on this information and this inspection that I did? You betcha. I have no problem whatsoever. These cylinder heads, in my mind, are right up there with any other street level cylinder head that's on the market today. No problem running these whatsoever. I'm very, very impressed with them. Every little detail of it turned out perfectly. The runners were all the same size. They were as advertised on the intake side. Very, very impressed there. The chambers were perfect. Very impressed there. And the run out and everything was good on the valve job. So, again, I couldn't be more happier for the amount of money that these cylinder heads cost and the value that you would get out of them. No problem at all. I will leave a link to everything down below. The tools that I use, the cylinder head, and the kit that came with this. I'll leave all that down below so you can take a look at it. But again, very, very happy with these. If you have any questions on what I did, how I tested them, how I CNC'd them, how I checked the run out, anything at all, please don't hesitate. Leave them down below. Don't forget to like the video, subscribe to the channel, please. And I appreciate y'all watching. I'll catch you on the next one. See ya.